Okay. So try to get a variety of different problems. So again, I'm going to go through the test, work a lot from each, and then move on to the next test. And we only had 3 tests, so there's only 3 tests for me to go over. So I'm going to write the problems down and then work them from there. So this is from the Unit 2 test, inequalities test. The first test we took this 9 weeks. So first step, what do we do? What's the first step in solving this equation? Anybody want to take some guesses? You can type in the chat box to me privately so no one sees it. First step in solving this problem. Parentheses, someone said. So yes, we need to distribute that 7 to everything inside that parentheses. So that would be 3x, just bring it down, minus 7x, and then negative 7 times negative 3 is a positive 21, right? Negative 7 times negative 3, positive 21. And then negative 7 times x is negative 7x. Okay, so we've taken care of the parentheses. I'm going to just rewrite everything else. This sign looks jacked up. It doesn't matter. Okay, so now we've done the parentheses. Now what do we need to do? Like terms, right? This is a like term and that's a like term. They both have just 1x with them. So 3 minus 7 is negative 4x, right? And then just rewrite everything else that we aren't changing. And now this just looks like an equation, which we should know how to solve equations, right? So after adding the like terms together, we're trying to get this x by itself. This 4 is directly with that x, so we can't move that 4 yet. So we need to move this positive 21. To undo addition, what do? We subtract, right? To get it to the other side. So that would cross out. And you would be left with, still have this negative 4x. And so calculator, I know y'all, if you don't have a calculator at home, Desmos, if you type in Desmos Scientific Calculator, it will come up with a calculator that will give you the same stuff as what I have like on my calculator. So negative 13 minus 21 is negative 34. And then again, trying to get that x alone. So now we can mess with the 4, right? There's nothing else to do. This is being multiplied. How do we undo multiplication? We divide, right? Divide by negative 4. Now, this is where inequalities and equations are different. Equations as in like this. Equations have just equal signs. This has an equality sign. When you divide by 4 here, nothing changes. What's this? I don't know if but here when we divide by that 4, what happens? Do y'all remember when you divide by a negative number, what happens? Can anyone tell me? Y'all, never mind. The sign changes, right? So, because we divided by negative 4, it flips. Right. And y'all, I wrote the problem wrong. So that's why we got a fraction. I like to give just whole numbers most of the time. This was supposed to be a +3 right here, and I put negative for some reason. I knew I didn't have a fraction, but either way, that could be an answer. I mean, you can get fractions when solving for, but that was a mistake on my part. All the work's right. I just originally wrote the problem wrong. So the work's right for the problem, but all right, let's work another one. Did everybody understand that? At least somewhat? It helps more if you don't understand it and you tell me, because then I can see where you got confused at like what step. Okay, we'll work another one. We'll see. We'll see if we can. Sometimes it takes more than just one example. So let's just work another one and see if we understand it a little better. Was going to do a harder one. Let's do an easier one right now, just to refresh our memory. Okay, so this is the problem. So for this problem, we need to get the x's together on one side, and then the constants are just the numbers on the other side. So you can either move this 3 over here and get the x's on this side, and then move the 6 over and get the numbers on this side, or you can do it the opposite way. You can move the 2 over here so the x's are on this side and then the numbers on this side. Whatever you want to do. I think I'm gonna just move the x's to this side because that's what like you normally see is the x's on this side. So this is a +3 right now. If there's not any kind of operation in front, it's understood to be a positive number. To undo the addition and to get this to the other side, we need to subtract. We need to do the opposite. So I minus it from this side and it cancels out. Minus it on this side as well. So what's -2 minus 3? -5x, right? And then I'm going to just rewrite everything for right now. That canceled out, so it's gone. So now I need to get the numbers on this side because I'm trying to get this x by itself, right? I need that x to be alone. That's the goal. That's the whole point. So I can't mess with that 5 right now because it's directly with it. So I need to move something else. So that's when the 6 comes into play. It's a +6 on this side. So to move it to the other side, we subtract it from both sides so that would cancel out. I'm going to just bring down the 5x and the sign. And -34 minus 6, -40. And then the last step being trying to get that alone. So I got to get rid of that 5. It's being multiplied. To undo multiplication, we divide. That would cross out. And so on this side, all you're left with is x. What about this sign, though? Did we divide by a negative number? We did, right? So that sign changes. It flips. If you divide by a negative number, the sign flips. And so negative 40 divided by negative 5 is a positive 8. Did that make sense? Okay, and with inequalities, we have something that we learn is interval notation. So what number could we put right here to make this true? What number is less than 8? Less than or equal to 8? This is saying less than or equal to. What number is less than or equal to 8? Any number. I see a 7, 6, and then 5, 4, 3, 2, 1, and then on into the negatives, right? So the interval notation for this, any negative number, it goes on into negative infinity. I can continue 4, 3, 2, 1, 0, negative 1, negative 2, negative, and it could literally go on forever, right? Because all those numbers are less than or equal to 8, right? Does that make sense? And this has a parentheses because any infinity is going to have a parentheses, and this is a bracket, remember, because it has the equal to with it. This is just parentheses, but this is brackets. But you never put a bracket around an infinity sign. Does that make sense? Do y'all remember that? I know that was at the beginning of the 9 weeks, so it's been a little bit. Do y'all remember that? Anyone let me know? And then say we had a number line. Here's my number line. 8 is the magic number, right? And again, it's greater than or equal to, and with this, it's also a closed dot. And if y'all need to write this like thing down, so greater than or less than, I said that backwards, but it's going to be parentheses with an open dot. And then greater than or equal to and less than or equal to brackets with a closed dot. So the 8 has a bracket, right? So it's a closed dot. And which way do these numbers fall? Should we draw the line this way or this way? To the right or to the left? Do these numbers fall to the left or to the right? We even wrote some of the numbers out. 6, 5, 4, 3, 2, 1. Where are those in comparison to this dot? They're to the left, right? 3, 4, 5, 6, 3, 4, 5, 6. So, and again, guys, I don't know what the test is going to look like. They're making it on, they've already made it on ELS. We didn't have any say so. So I'm really hoping everything goes smoothly, honestly. I'm hoping there's nothing that, y'all haven't seen. Okay. Did this make sense? Kind of. The more problems you work, the easier it is and the better you'll get. Okay. I'm about to give y'all this one's a harder one. Not harder, but more steps. Okay, so anytime you see parentheses, and we see it on both sides of the inequality, right? You do the parentheses first. Always do the parentheses first. So you see there's not a number in front of here, right? There's just a minus sign or a negative number. If you won't, put a 1 in front of that, just so it's less confusing. If you won't, you can put a 1 in front of it. It's understood 1. Okay, so we're not doing anything with this, right? Because we need to do the parentheses. So I'm going to just bring that 5x down. Now I need to distribute the number that's on the outside of the parentheses to everything that's on the inside. So what's negative 1 times x? Negative 1x, right? Or negative x. You can either write it like that, or again, you can put the 1 in front of it. It doesn't matter. Now, what's negative 1 times negative 2? Positive 2, right? So we've taken care of this parentheses, right? So we're done with this side. So let's write that inequality sign and let's do the other side. This negative 4 is what needs to be times by everything on the inside. So I'm going to just write the 2x down. And if it helps to like cover up the equation that you're not working with. So what's negative 4 times x? Negative 4x, right? And then what's negative 4 times negative 8? A positive 32. I want to show y'all. I'm just going to share my screen real quick because I want y'all to I want to show y'all. If you type in Desmos Scientific Calculator, if you don't want to use your phone, here's a calculator right here. It has a square root, a squared button, absolute value, has fractions. So if you do not have a calculator like I'm using, which I know most of y'all don't, please pull up Desmos if you don't want to use your phone. I just wanted to show y'all that real quick because they're expecting at least the foundations of algebra to use Desmos. Okay, so we've done the parentheses. So now after parentheses, the next step is to combine the like terms on the sides. So like we see the 5x and the minus 1x. Those are like terms, right? And then on this side, the 2x minus 4x, they're like terms. So let's add and subtract those. What's 5 minus 1? 4x, right? I'm not including the x, just know that the x is with it. Sometimes it's easier to just look at the constants and then just bring down the x with it instead of saying what's 5x minus 1x. So, and then just bring, there's no other kind of number on this side, right? There's not a +3 with it. So we can just bring the +2 down. And we're done with that side. So let's bring the inequality. And now this side, what's 2 minus 4? You have $2 and someone takes 4 of them from you. You only got $2 and someone just took 4 of them. So you have -2x, right? I know some of y'all probably would have said this is just 2x. But you have to look at how the numbers are. If it helps to think in money, do that. And then just bring over the +32. And then this looks like the equation that we started with on that last problem, right? So we need to get the x's to one side and then the numbers to the other side. So this is a -2x. I'm going to add it to get it to the other side. That one will cross out. 4 + 2 is 6x. Bring down everything else that's crossed out. So I need to get this, again, the x needs to be alone. We cannot mess with the 6 yet because it's with that x. So we need to get rid of this. It's being added, so we need to subtract it to get it to the other side. And then again, getting that alone, this is being times together. To undo multiplication, you divide. And we don't flip the sign this time, right? Because we divided by a positive number. And so this would be the answer if it asks for the answer. Now, what numbers make this true? Give me some numbers. What numbers make that true? What number could I put in here that would make that true? Okay. Someone said 6. The number sign doesn't flip this time because we divided by a positive number. If that was a -6, then we would have flipped it, but it's a positive, so we don't. So any number, so the numbers that would satisfy this, a 5 would, right? Because it's saying greater than or equal to. So 5 can because it has equal to. Yep. 6, 7, 8. Someone said 75. Yep, 75 works because it's just going to continue to go on into infinity, right? 75, 175, 275, 1,075. It's going to keep going into that positive infinity direction, right? So that is why the interval notation for this one, we see it's greater than or equal to. Remember, greater than or equal to or less than, it's brackets, closed, parentheses, open. So greater than or equal to, so it's bracket 5 into infinity. Remember, the infinity signs always get a parentheses. You will never have an infinity sign on this side or that side and have a bracket. It has to have a parentheses. Do we understand why this is the notation? And again, it helps me more, I guess, if you say, no, I don't understand, because I can explain it again. But any numbers make this true. 5, 6, 7, like I said, 100, and someone said 75, 180, a million. A million is greater than 5, right? I'd rather have $1 million than $5, I'll tell you that much. So that's the interval notation, 5, and it goes on into infinity. So I had a number line. Zero, 1, 2, 3, 4, 5. Okay. Probably should have did different numbers. Normally you already have a number line there. You won't have to draw it, but so 5 is the magic number, and we know it's a closed dot, right? Because it's greater than or equal to. And then what way do we draw the line? We put out some numbers here. So we see a 6, 7, 8. Where are those numbers at compared to where that dot is? To the right, right? So it would go that way. Anybody that this doesn't make sense, let me know. I'm probably only going to do one more problem of an inequality, and then I'm going to let you go. And then I guess tomorrow we will do the system of equations, and I want to say linear, but I'll just have to see. So I'm going to do one more problem, and then you guys are going to be free to go. Or if you think you got it, y'all can let me know, and I won't do another problem, and I'll let y'all go a little bit earlier. I just need to know. I do want to mention real quick, though, you will have some that will be like this, and it will have the word or. And guys, you solve it the exact same way. So you solve it the same way. So I was minus the 5 over 21, and then x negative 7. You just solve them separately. And I'm just going through this real quick. Y'all don't have to write these problems down. So you would just have two different solutions, meaning you would have two different interval notations, and then so like less than negative 7. So negative 8, negative 9, negative 10, negative 11, those kind of numbers. So it would go into negative infinity is what I see. 2, 7. And they're both parentheses because it's just a less than sign. And it helps me even writing the numbers out, like, okay, what makes this true? Negative 8, negative 9, 10, so on and so forth. And you can see a pattern. You see that that's going into the negatives, the way negatives. On this one, you saw that it was going way into the positive. So that's how you know whether it's going into infinity or if it's going into negative infinity, right? Y'all see that? And so like this one, greater or equal to 1, 2, 3, 4, 5. And you see where it's going. So bracket, because it's greater than or equal to 1 into infinity. And then the number line, one, open dot on 7, close dot on 1. When they were going into infinity, infinity is this way, right? This goes into the millions. This one went into negative infinity. So with or, I just want to show y'all the graphs go the opposite way. Y'all will have, let me get a problem real quick. That has and. It doesn't say and, it's going to look like this. When you get a problem like this, these are the two signs. When you get a problem like this, so we need to get this alone. Same like the other ones, we can't do anything with that number that's directly with it, so we need to move this positive 1. We minus on both sides. So that crosses out. 3 minus 1, 2, 2x, 12. And then we're trying to get along. That's being multiplied. So we divide both sides. And so this answer would be 1 is less than x, which is less than 6. And you see there's only a set amount of numbers that fit in here, right? Only 2, 3, 4, and 5 will fit into here. So the interval notation for this one would be 1, 6, both with parentheses, because it's only a greater than, less than sign, not less than or equal to. And so obviously the graph is going to look like 0, 1, 2, 3, 4, open dots. And you see the numbers. So these are the numbers that it satisfies. When you're doing the number line, you're just simply making darker the numbers that would work. Like 2 works in here, 3 works in here. I know these were a little bit fast, but does that make sense to everybody? Did anybody get confused? Do we think we're good on inequalities? I think that if after just right now, if you don't think you're good, maybe go back to the Unit 2 inequalities review. And I'm pretty sure I have unlimited attempts on that. You can go back and do all the problems and see if you do good. And if you're good, then, that portion of the test you're going to pass with flying colors. So tomorrow we will do system of equations, and then we'll see about linear. But go back and practice on, that would have been like under maybe week 11. So at the very beginning of the 9 weeks, go back in the modules to week 11, go to the inequalities review, and if you have any questions, message me. But I will see you guys tomorrow. If you have questions about anything, stay on after and I can answer them. But y'all are good to go if you're good. Again, if you're missing tests, please do that. Hold on, I'm messaging some of y'all. I hope y'all don't get off. If think that's everybody.